Hey guys, happy Thursday. So we had a question in the Ask the Faculty section. Could faculty go over or do a short video just to go over maybe some practice questions and to go with the flow rate, etc., for the upcoming high stakes med and calculation administration test. So, anyway, I took the practice test that y'all have on Blackboard and just went over some. And I just want to, and I actually did the questions. And I just want to go over some with you right now. And so let's just look at the first one. It says the physician has ordered D5.5 normal saline to run at 100 mLs an hour with a drop factor of 20 drops per ml. So how do you calculate that IV flow rate? So you notice that I highlighted round to the nearest whole number. Now you do that at the very end, okay? So basically what you want to do is you take your amount of mLs, which is 100, and you times it by your drop factor. All right, no, actually, sorry. You take your 100 mLs and you divide it by your 60 minutes and you times it by your drop factor of 20, and that equals 33.33333. And it says round to the nearest whole number. We have given you directions of what to do in order to be successful on this test. So the answer is 33 drops per minute. All right, do y'all all see that? Pretty self-explanatory there, all right? 100 over 60, which is your minutes, times your drop factor of 20. Number 2, here we go. The doctor has now ordered 1,000 mLs of lactated ringers. It could be lactated ringers, it could be normal saline, whatever. But it's 1,000 mLs of it to run over 6 hours. So what is the correct IV flow rate to set on the infusion pump? Again, I highlighted round to the nearest whole number, and you don't do that until the very end. So you're going to take 1,000 and you're going to divide it by the 6 hours. And that equals 166.6667, what have you. Anyway, it's saying just round to the nearest whole number. So what is that answer? 167. Remember, 5 and greater, you round up, okay? So that would be 167. All right? Any questions with that? Please get with your instructor. All right, so this next one it looks real complicated, but what I want you to try to think about is, what is the doctor asking you? What is the desire? What did the doctor ordered? The desire is for your for your patient to receive 500 milligrams. Do you see that? 500 milligrams right here. And so you're going to put desire. Now, what do you have? All right. So what you have is 250. All right. Right here. And the stock that goes with that is 1 ml. So it is your desire over have times stock. And that equals 2 mLs. All the rest of that is just a bunch of fluff. All right? Just think about what the question is and what the doctor is asking for, and then how it comes. So what is your desire? What that means what the doctor ordered. What do you have in stock? Times the ml, and that equals 2. All right? The next one is the client is to receive lactulose syrup. Oh my, that's going to be painful, guys. Lactulose, you better be ready. 60 grams via nasogastric tube, okay, an NG tube. And the medication is available as lactulose syrup, 10 grams per 15 mLs. So what it's asking you here is, how many milliliters does the nurse need to administer? So what is their desire? 60 grams. It is, what do we have? Is 10 grams. So we divide that and we times it by our stock. So desire over have times stock. Desire over have times stock. Okay? And that equals 90. I didn't do the other. Y'all got to know that. I'm just working on IV calculation and that kind of thing. You need to know your kilograms and conversion. If you have any questions about that, reach out to your professor, okay? The next one is the client is to receive doxycycline sodium, 0.2 grams PO. What is the dose of the medication in milligrams? So you're going to have to convert grams to milligrams. So how do you do that? You take and move that decimal. So you're going to go 1, 2, 3. That's 200 milligrams. You move it to the right, all right? You move that decimal to the right. So it would come behind the 200. So that is your 200 milligrams, all right? Any questions? Get with your instructor on that, okay? Here's your next one, number 9. The client has 1,000 mLs of normal saline running at 50 mLs an hour. Picture that at bedside. You've got that big bag of 1,000 milliliters running at 50 mLs on your pump. Now we need to know how many hours do you have in anticipation of changing that IV bag? When is it going to run out? So the formula is you take your total volume, which is your 1,000 milliliters, and you divide it by your flow rate of 50 mLs an hour. All right? And that equals 20 hours. So you can anticipate it hopefully not happening on your shift. I hope you're not working 20 hours. Maybe the next day, but definitely 20 hours. Do you see that? Take and switch things up a little bit. Make your own practice questions, okay? Y'all work together, maybe do some Zoom calls and do your own and help each other and support each other in that fashion. Once again, this one, number 10, is the doctor's ordered that normal saline to infuse at 75 mLs an hour. Think about what that looks like when you go to the Pyxis and you see that you have maybe an antibiotic, all right? Your drop factor is 10 drops per ml. That means how fast it's going to go in, okay? What is the correct IV flow rate? Once again, I've highlighted at the end, round to the nearest whole number. So when do we do this? Not until the very end, all right? So we're going to take that 75 mLs an hour and we're going to divide it into 60 minutes, all right? Because that's 1 hour, 60 minutes, times 10 drops, and that equals 12.5. Can you program 12.5 into the pump? You can, but you don't see that very often except like in CCU or some minute when you've got to be just down to the bare bone minimal. But what do your directions say? Your directions say round to the nearest whole number. So that's what we want you to do. So it's 12.5. Remember, anything 5 or greater, we round to the whole number, which is 13. Whoops, I forgot to put 13 here. All right. The next one, the doctor has ordered your antibiotic, and it comes in 1 gram and 250 mLs of D5.5 normal saline for you to administer over 1 hour. Plain and simple. 250 over 1 hour equals what? How fast is it going to go in? What are you going to set your pump to? 250 mLs an hour. All right? So that should make sense. All right, number 12. The doctor has ordered once again a bag of fluids, 2,000 mLs. That's a pretty big bag over 12 hours. All right. So I would say that that's going to run at a really fast rate. How many milliliters per hour will that client receive? All right. So we'll set it up. We have 2,000 mLs, and the doctor wants it to run over 12 hours. So we divide that. It's going to equal 166.666, whatever. But we know anything greater than 5, and it's telling us right here, round to the nearest whole number. We need to go ahead and round up because it is greater than 5. It's a 6, 6, 6, 6, 7, whatever. And it continues. So we're rounding to 167 mLs an hour. Okay, I hope all this is helping you and just giving you a little bit clearer definition of why we're doing what we do. So important. All right, 13. The nurse has to administer that fentanyl. It comes in 80 micrograms. IM, 30 minutes prior to surgery. So that's when they want you to give it. And the med is available as fentanyl citrate, 50 micrograms an ml. So how many milliliters does the nurse need to administer? So what you're going to do, you're going to take that 80 and you're going to divide it over the 50. So what is our desire? 80. What is our have? 50. All right. What is our stock? 1. Okay. And what is it? When you divide it and times the 1, it's 1.6 mLs. So once again, desire over have times stock equals 1.6 mLs. 14, your patient is to receive a solution which is 250 milligrams PO, all right? And this medication is available as 125 milligrams. So you can see per 5 mLs. You can see the milligrams to the milligrams. It's good. So we can take and we can divide that. All right. So what is our desire? That's 250. What is our have? 125. What is our stock? Times 5 mLs. And so how many milliliters of medication would the client receive? 10 mLs. Perfect. You got it. And what's the next one? All right, I see. Oh, this is a lot of information here, guys. So again, there's a lot of fluff, all right? So you've got to decipher exactly what the doctor is to receive. What is your desire? What is your have, okay? So work through this problem, cross out what is the fluff and the stuff that you don't care about because you've got to come up with the desired amount. So here you go. The client is to receive 750 milligrams IM every 6 hours. So what's your desired amount? 750 mLs. Do I really care about that every 6 hours? No. They're asking us, how many milliliters does the nurse need to administer? They just want to confuse you here, okay? So 750 milligrams is your desire because that's what the doctor ordered. What do you have? You have 500 milligrams of cefazolin, all right, per 1.5 mLs. Desire 750 milligrams over what is your have? 500 milligrams. And then what is your stock? 1.5. And that equals 2.25. What does this practice test tell you to do? Round to the nearest tenth. So what is our nearest tenth? It would be the 2. So what is your 5? So it's 2.3. All right. So you've got a round. I hope that makes sense to you. I have just a couple more. Number 16, let's look at that one. And that says, the nurse has to give filgrastim 300 micrograms sub-Q every day for 2 weeks. Okay, well, that's nice. This sub-Q every day for 2 weeks, that's just fluff, guys. So what is their desire? All right, 300 micrograms. All right. The medication is available, so that's what we have, right? 100 micrograms. And what is our stock? 0.3 mLs. So it's asking us how many milliliters of medicine would the nurse draw up in the syringe? A desire, 300. You divide it into 100. That's our half. And then we times it by 0.3 stock. And that is 0.9 mLs. Okay? And the last one that I did, the rest I did not do. Whew. 17. The client is to receive digoxin. All right, y'all know what to do with digoxin. Remember, you got to listen for that pulse, right? At the apical. All right. Is 0.125 milligrams PO every day. All right. So what is the dose on this medication in micrograms? So you need to do some conversion. All right. So now you need to convert to micrograms. From micrograms, to milligrams. All right. I said that wrong. You need to convert from milligrams to micrograms. All right, hold on, guys. It's been a long day. I've been in practicum all day. I need to convert from milligrams to micrograms. That is what I need to do. From micrograms to milligrams. Don't judge me. So what are we going to do? We're going to convert. As you can see, we're going to move that decimal and we're going to count 1, 2, 3. And when we move our decimal behind the 5, that makes it 125 micrograms. Pay attention to all the different micrograms to milligrams and don't confuse yourself. Remember, you cannot, if you have a microgram and a gram, you have to do some kind of conversion in order before you begin your problem. Know that, okay? So this is great practice to see that. So if this was 3,000 grams right here, you would need to correct your problem before you would even move forward with your answer. Okay? Alrighty, well, that's all from Miss Fall. I hope y'all are having a great semester, and reach out to your instructors should you have any questions at all. But as per your request, this is a short video. Someone else had asked about some practice questions, some more practice questions. I recommend that you open up that Hinkle Med Math book. I believe they have some Q&A in there that you can work on. You can also, once again, set up and do a Zoom and make up your own practice questions among each other, and y'all can share your questions on Zoom, like during your study groups. And you can also go out to the web. There's tons of questions out there, free ones that you can use. Or reach out to your instructor as well. I personally don't have any questions. I can make them up and do it just like you could do in study group. But I highly recommend that you really take this practice test and this high stakes test coming up and very seriously and study hard. All right, here's to a great day.